Hi Senior 2 students. In this lesson I'll explain fifth and sixth properties of the representative elements. The fifth property is metallic and non-metallic property. Berzelius was the first scientist who classified elements into metals and non-metals. The opposite figure represents three types of elements in the modern periodic table, which are metals, nonmetals, and metalloids. Let's compare between metals and nonmetals. First point of comparison, the valence shell of metals has less than half of its capacity of electrons, where the full capacity of electrons in the valence shell is 8 electrons. Therefore, the valence shell of metals has 1, 2, or 3 electrons. On the other hand, the valence shell of nonmetals has more than half of its capacity. Therefore, the valence shell of nonmetals has 5, 6, or 7 electrons. Second point of comparison, metals have large atomic radii, leading to small values of ionization potential and electron affinity. On the other hand, nonmetals have small atomic radii, leading to high values of ionization potential and electron affinity. Third point of comparison, metals are electropositive because they have ability to lose valence shell electrons and change into positive ions to reach the structure of the nearest noble gas. The most electropositive element in the periodic table is cesium, which is located at the bottom of the left side in group 1A of the periodic table. On the other hand, non-metals are electronegative because they have ability to gain electrons and change into negative ions to reach the structure of the nearest noble gas. The most electronegative element in the periodic table is fluorine. It's located at the top of the right side in group 7A of the periodic table. Fourth point of comparison, metals are good conductors of electricity because they have large atomic radii, so it's easy for few valence electrons to move from one position to another. On the other hand, nonmetals are bad conductors of electricity. They are known as electric insulators because they have a small atomic radii, so their valence electrons are strongly bound to the nucleus and difficult to be transferred from one position to another. The third type of elements in the modern periodic table are metalloids, which are characterized by the following properties. Number one, they have metallic appearance and the most properties of nonmetals. Number two, their electronegativity is intermediate between metals and nonmetals. Number three, their electroconductivity is less than that of metals, but more than that of nonmetals. So they are known as semiconductors, and they are used in manufacturing transistors. What is the graduation of metallic and non-metallic property in the periodic table? In the same group. In group 1A, the metallic property increases by increasing atomic number due to the increase of atomic radii and decrease ionization energy. What do you expect to be the most active and strongest metal in group 1A? Cesium is the most active and strongest metal in group 1A in the periodic table. In nonmetals in group 7A, non-metallic property decreases due to the increase of atomic radii and decrease of electron affinity. Then, what is the most active and strongest nonmetal in group 1A? 7A. Fluorine is the most active and strongest nonmetal in group 7A. Let's move to explain the graduation of metallic and non-metallic property in the same period. As we go from left to right, and by taking a third period as an example in the following figure, the period begins with the strongest metal in group 1A. Then the metallic property decreases gradually by increasing atomic number till we reach metalloids. And the period ends by the strongest non-metal in group 7A. Let's move to explain sixth property of representative elements in the periodic table, which is acidic and basic property. When an element combines with oxygen, it forms a compound known as element oxide. There are three types of element oxides, which are basic oxides, acidic oxides, and amphoteric oxides. Let's compare between basic oxides and acidic oxides. First point of comparison. First and second point of comparison. When metal combines with oxygen, it forms metallic oxide. The metallic oxides are usually known as basic oxides. Some of basic oxides are insoluble in water, and others are soluble in water, forming alkalis. For example, sodium oxide Na2O as a basic oxide soluble in water reacts with water to form alkali NaOH, sodium hydroxide. On the other hand, in acidic oxides, first and second points of comparison, when a non-metal reacts with oxygen, it forms non-metal oxide. The non-metallic oxides are called acidic oxides because they dissolve in water, forming acids. For example, sulfur trioxide SO3 reacts with water to form sulfuric acid. Also, carbon dioxide CO2 reacts with water, forming carbonic acid. Third point of comparison. Basic oxides react with acids, forming salt and water. For example, sodium oxide Na2O as a basic oxide react with acids like hydrochloric acid HCl to produce sodium chloride NaCl as a salt, and water is formed. But in acidic oxides, they react with alkalis, forming salt and water. For example, carbon dioxide CO2 as an acidic oxide react with sodium hydroxide NaOH as an alkali to form sodium carbonate Na2CO3 as a salt, and water is formed. The third type of oxides are known as amphoteric oxides, like aluminium oxide Al2O3, zinc oxide ZnO, antimony oxide Sb2O3, and tin oxide SnO. They react with acids as basic oxides and react with bases as acidic oxides. For example, zinc oxide as an amphoteric oxide reacts with acids like sulfuric acid H2SO4 to produce zinc sulfate ZnSO4 as a salt, and water is formed. Also, zinc oxide reacts with bases like sodium hydroxide NaOH to produce sodium zincate. Sodium is monovalent, zincate ZnO2 is divalent. So the chemical formula of sodium zincate is Na2ZnO2 and water is produced. What is the graduation of acidic and basic property in the third period? The basic property decreases and acidic property increases by increasing atomic number. But in the same group, which starts by a metal, like in group 1A, basic property increases by increasing atomic number. But in the same group which starts by a non-metal, acidic property increases by increasing atomic number. And this is due to increasing atomic radii, leading to the decrease of attraction force to hydrogen atom. Thank you for listening and goodbye.